Okay, welcome everybody. This is Microservices winter term 2021. We have January 18th or something like that, and it's the second lecture in the new year. And we are going to do persistency. So, what we have by now is we have a warehouse web client built with React, and we have connected it to a warehouse web service built with Express. And none of the data that we enter so far ever reaches a solid state disk. So as soon as we are running out of power, all our data is lost. So if we do a review or restart in our browser, the browser loses all its local memory or heap memory. And when we restart the warehouse service, it also loses all its data, or when we stop it. So we need to do this persistently. And when it comes to persistence, it finally becomes visible that we need to do with multi-user support. We have multiple people that are going to use our service, and therefore we need to deal with that. And I need to go back into history a little bit. In the 80s and 90s, so some 20 years ago, or 25 years ago, there were very little options. So the internet has been invented in 1990. And so before that, actually, when I started my computer science studies, there was no connection between computers. There were one computer, you were using that computer, that's it. They were not connected to each other. And on the big computers, you could actually attach multiple terminals, which were monitors and keyboards. We did not have mouse pointing devices at those times. And well, actually, even when the very first PCs came up, then everybody had his own computer with his own disk. It was something at the late 80s. Those computers were not connected to each other. They could not send each other messages. It was actually hard to get an email. You needed to connect to the phone line. It was horrible. So after all, what you did is you put your data on a floppy disk. So these days it would be a USB stick, a memory stick. And then you put it out of your computer, go to the next computer of your colleague, and then you give him the file, the data that he wants. So to overcome this, finally, we developed the relational databases. Relational database systems were the very first, when computer became connected, that were able to deal with multiple programs, people working on the same data concurrently. And finally, what they did, they came up with this ACID transaction, atomar, consistent, ED, I have no idea, durable and independent or whatever. The basic thing is that they really had a hard time to come up with a solution that really allowed multiple people to read and write on the same data concurrently, and they took some 10 years to get up with something reasonable that really worked, and that dominated our persistent data for multiple users for about 30 years. So from that on, when we had the common database, that was what we were doing. And in the very first time, we have had programs running on different computers, and those programs were working on the same database. That's basically the idea that we were having. So we have had the application logic or business logic or whatever it is separated between multiple users, multiple computers, and the graphical user interface attached to a desktop program that was then working on a common database. And the point where this became complicated were when the system grew and you said, oh no, it's not only multiple people working with one program on a database, but they started to come up with multiple programs. So there were one program for the warehouse where we could actually order data, order goods and store them in our warehouse. And one where there was a shop where you could actually buy from these things that are in the warehouse. And these are both, in this picture, two different programs and that were working on the same database. And actually this approach was not working very well because when those people that developed the warehouse were changing something in the common database, and especially when they are adding new tables, relational tables, or new columns to a table, that would frequently break the code of the shop. And vice versa. So actually it was very hard to decouple these two programs from each other. Any change that is done to the common database would affect the other program too, and you would need to update both of those programs simultaneously in order to go on to a new version of your database. In addition, it became very, very hard actually if you would like to do a major extension, a new release of your application, your overall structure, that involves changes to your database that are somehow incompatible to the old versions. Then you actually had to do multiple things. You needed to set up the new database, migrate the data, and then go to all the places where your application programs are living in different computers and exchange those or update those to new versions. And at those times, updating a new version of a program actually meant send out a CD, a disk, a medium, a hardware device thing with a USB stick with the memory on it, per snail mail as a packet. You couldn't send it via the net. Downloading time for such big programs were just too large, it wasn't possible. Okay, so that all together became our development towards so-called web services or web-based systems. And that began in 1995 when James Bernard-Lee actually invented the internet, when the URL was invented. It was actually 1990 it was started, and I think the URL was 1995, about that. Around those days, early 90s, they came up with these ideas, and the very first web browser, Mozilla, that was about 95 something when they have had that, a little bit earlier. So at these days it came widespread, and the idea was to have still the relational database, to have a web service on top of it, which contains all the business logic, all the, program code. And actually, this one was working in multiple threads, so concurrently, and dealing with the users concurrently. So we have multiple users in browsers. So the web browser came up, and you could have different websites that were referring to the same browser actually. And at the early days, actually, we didn't have these single-page web applications, but actually HTML was rendered as the server side, and we sent out static web pages, but that's not a major difference after all. So actually, you have had multiple people using some websites, pages that are related to warehouse or shop, and all those requests will be sent to a common web service that covers all the functionality that works on all the common data. That's basically the system idea till 2010, 15, till 5 years ago, 10 years ago, basically. We were building all our systems that were having multiple users this way. So SAP, the major vendor of enterprise resource planning systems, so the worldwide spread software for administration, they use this model. They actually have one database per enterprise, where all the data of that enterprise, all the goods, all the purchases, everything is stored, all people, all money, and one big service on top of it, which is basically a web service, and then clients all over the places. So this was dominating the architecture of multi-user systems for about 20 years. That's back. It's in computer science terms. This is really a long time. So usually we change paradigms all 5 years, and if something lasts for 20 years, it's damn stable. It's really a very successful system story. However, oh, damn it. Do I have new batteries? Yeah, here is battery. Yeah, I have it. Okay. Sorry, this will take some time and you won't. Do you hear me? Great. So here we are again. And we are still discussing history of multi-user applications. And there was this very successful story of common web services based on a single common database. These things were so successful, they grow and grow and grow and scaled, and more users, more data, more functionality, such that finally they are breaking down on their own weight. These systems became that large that you cannot manage them anymore. It is becoming harder and harder to maintain them, to extend them, to actually run them, and to make them work. So if you don't believe it, ever speak to somebody who is updating an SAP system, an enterprise system for an enterprise like Volkswagen. If you would like to, put a new version of their administrative software to Volkswagen, it's a good risk to kill Volkswagen, because they might be out of order for weeks because the software is no longer running. And there are cases where big enterprises were bankrupted by introducing SAP. And so that's really a big problem. These things become a major fault. So, therefore, microservices have been invented. And the idea is to split this thing apart. To do not have one big service that covers everything, an enterprise-wide data model and web server, but have multiple small of them, and let those small web services talk to each other. And then you have multiple databases at the bottom of each of those. And the point is, you want multiple databases. And as soon as you go from one database to two databases, you lose ACID transactions. And ACID transactions have been for 30 years the means to coordinate work of multiple people. And it's really prominent, everybody knows it, and people tend to stick to it. And if you go to microservices, the very first thing that goes down the road or down the hill is ACID. Our atomic consistency and all this is not going to be guaranteed if you have two things. The problem is, if you update something in here and in addition, simultaneously, something in here, that update might work, that update might fail for some reasons, and then you have one database which is, one transaction ahead and the other one is behind, and those two are no longer consistent. And these kinds of consistency is going to be lost. There is a famous theorem that tells you can't have it, distribution and consistency at the same time. And this problem has been studied for some 10, 15, 20 years now. And actually the first people running into that were Google, Facebook, Amazon, those big ones. They had so many users, especially Google, that they couldn't work with a single database anymore, with a single computer anymore. They couldn't answer several millions requests per second on a single computer. So they need to split it up on multiple computers, and not only multiple computers, but also multiple database systems, because also their database system was no longer able to handle this amount of transactions. And then they said, okay, yes, we are losing ACID. Well, actually, we just store data about web pages and URLs and where they go to and what they are talking about and keywords for those. If we have some 2, 3, 4, 10, 1,000 databases, and they are not really all up to date, but some were a little bit ahead and some are a little bit behind, we don't care. So just live with it. And they introduced the concept of eventually consistency, which says, we will manage that at some point in time in the future, we will have updated all of our databases. Until then, some of them will be behind the other. Live with it. That's the point. And actually, oops, that's a bad thing. So that was actually one of the reasons why it took so long to come up with this microservice idea. That you really need to get rid of these ACID transactions and live with eventual consistency. The big enterprises were actually creating NoSQL databases. So NoSQL is not only SQL, it actually says no SQL, do not use SQL at all. So currently MongoDB is the most used or most prominent or most recent kind of this database. There are other databases in this idea too, and let's just talk for Mongo. So those databases are basically key value stores. They have just a key and a value. The value might be a JSON document or a complicated data structure, but basically that's it. You have keys and values. And you do not have those relations between those. That might be a drawback, but actually the relational data model was all the time a problem from the software engineering point of view. So I'm a software engineer, I like object-oriented data model, and well, object-oriented data models with inheritance and these kinds of stuff, and relational data models with tables and columns and primary keys, there is a so-called object relational gap. It was all the time really, really hard to store object-oriented data into relational databases. But there is a lot of work has been done. There's the Java Persistency API, JP. There's a lot of hyphenate or such a thing. Libraries has been developed that help you a lot of that. In the area of JavaScript and TypeScript, you would use something like type ORM. Type ORM, it's object relational mapping that help you in you give them classes, they create the tables that are able to store these things. It's a pain after all. And most important from a software engineering perspective, relational databases do not like to be evolved iteratively. It's pretty hard to update a relational database. You can actually do all the things that you would. There have been tons of work on that. You can add new tables, no problem. You can add a new column to an old table. That's a tricky thing after all. Well, actually, most databases support this. However, if you do it while programs are working on that database, that's scary. If there is somebody adding a new row to your table and he's still using the old data schema, while the database is actually reorganizing. If you add a new column to that table, it's actually going to go through all the rows and actually create a copy and have extra space for this new column. And while it is doing that, it's a pretty bad idea to add new columns to that table, new rows to that table, new data to that table. It has been done. There are sophisticated techniques for that, but basically don't do it. And if you are not allowed to do that, it means you need to shut down your system for about, 1 day, half a day. Evolve the data, add those new columns, and then you can restart your system. Shut down the system. For many enterprises, it's okay if you do this at the weekend. on Sundays. It's not okay if your name is Google. You cannot shut down Google for 24 hours. You cannot shut down Google for an hour. You cannot shut down Google for 5 minutes without reading it in the newspapers the next day. So that must not happen. And so relational databases are really a pain if it comes to model evolution and iterative software development. And yeah, it's so hard. And therefore, NoSQL databases like Mongo are pretty relaxed on that one. They actually give up strict typing for the documents that you store or the data that you store for the values that you store for a key. You can store any value for any key. It needs not to be really to have a certain structure. It can have, well, one big map with keys that store persons and other keys that store products and other keys that stores suppliers and these kinds of stuff. And even if there are keys that store products, the different product values might have a different format. So actually the Mongo database doesn't care. And then if you do a query and say, I would like to have a vendor with this email or a supplier with this email address, then it goes through all its data and looks for those records that have this field, and then it actually looks it up. You need some more runtime type information to do that. Well, actually table must, column now needs to, no, actually any, value needs actually to tell I consist of these fields. That is something that you could omit in a relational database because all the rows in a table have the same structure. However, it's much more flexible, evolvable, and scalable, and all the kinds of things that you could dream of. And therefore, we are going to migrate towards NoSQL databases. We are no longer using object relational mapping, and we are going to use do not use eighth transactions anymore, but we use eventually consistency as a concept. And eventually consistency comes with workflows, and we will discuss that during the lectures. Basically, that's the point that I needed to point out to you before the lecture today, because, well, actually, we will use a relational database, but we will actually use it as a key value store, which is bizarre. It would be much more appropriate to use a Mongo database for this purpose. However, we are going to deploy our web services, the thing that you are programming. Each of you is going to set up a web server in the cloud. And actually we will use a platform provider which is called Heroku. And Heroku gives you, simple web service platforms for free. However, if you want more enhanced things, you need to pay for it. And one of the things that you need to pay for is if you want to use MongoDB. SAS. However, a relational database, exactly Postgres, you get for free. And therefore, we are using Postgres, but we will use it in a way that is similar to a key value store to a Mongo database. That's a long story. So the other long story thing is how do we deal with consistency issues? Here we use this Saga idea proposed by Chris Richardson in his Microservice pattern book. And this Saga idea actually says, which we were calling compensating transactions some years before. And actually what we do is we add data to both our stores, persistent stores, And then we have a workflow that says, okay, add some data here, then go for the other store, add some data here. If that fails, then do not a rollback, but then cancel the thing that you have done here, or well, do a reverse thing or undo thing. For example, the shop might place a customer's order for some shoes into the shop store. Then this thing is going here to the warehouse and saying, oh, please send Alice some red shoes. And then this warehouse says, oh, there should be some, but if I go to that place where they should be stored, there is nothing. They are all gone. They have vaporized. Oh yes, there is some, but oh my God, they have been. They are broken. You cannot actually sell them anymore. Sorry, they are broken. They need to go to the waste, and we need to cancel the order. So what they actually do is they send back an operation to the shop and says, we are sorry, we cannot deliver your red shoes. Here is your money back. And so in case of a failure in the second stage, we go back to the first store and do something that is compensating our first operation, and then we come to a new state. And because this is the collaboration of multiple stores, we need a workflow between those two stores, which is actually telling how this collaboration is organized and working. And this workflow needs to respect that things may fail. You initiate a workflow with multiple participants, and the first 1, 2, 3, 4 participants do as you expected, and then a very late participant says, no, sorry, stop, we can't do that. I fail, I'm not able to deliver this for you. I cannot execute this step. And then you need something that says, okay, if step number 5 is not able to do it, I go back to step number 4 and looking for an alternative. I ask someone else, go for another warehouse to deliver those shoes. And if I'm running out of alternatives, I go back to step 3 and said, sorry, I was promising that I could do that, but I can't. So please tell the customer I cannot do that. And then you actually cancel all those steps before and well, do something in order to get your whole system into a consistent state again. Okay. Evans developed the idea of domain-driven design, which was something like 2005 or something like that. Chris Richardson published his book on microservice patterns in 2015, and somewhere in between those two, they came up with these ideas for microservices. Note, we have 21 these days, so this stuff, what you are learning in this lecture or this course, it's about 5 years old, which is not that old. So it's pretty new ideas what we are sticking to. So let's dig into some code. No, before we go into code, you need to install a lot of things as usually. What you need is a Postgres database, and we use Postgres because Heroku, the platform provider that we are using, which gives you a free something, offers you Postgres as the database system in your free package. And in order to keep it that you do not have to pay for that thing, we need to stick to Postgres. In order to test these things, we set up Postgres locally on your computers. And you can also go for Heroku, create a Heroku account, and get a Postgres database from them. That would be either possible. However, it's more convenient if you install it on your local computer. If you're running on Windows, you can follow this link here. I hope you still have the link to the slides, and you can actually see, follow this link here. Or you Google for it, Postgres on Windows, download, something like that. For those of you who already use Docker, who is that? Anybody using Docker? One, two. Yeah, Azan is also using Docker, cool. If you use Docker, then just Docker pull Postgres will do the job. And actually, you can start the Postgres database. That's much easier and then doing this installation stuff here. We need a TypeScript library. It is PG for Postgres. And actually, you of course need also the types. I think it's slash or backslash, I'm not sure, for PG. It's slash or backslash? Slash. Oh, yeah, something like that. I'm not sure about. And then you can go, and that is your assignment. I have prepared that. So something that you also need is PG admin, I think 4, which is a program that I use to administrate the Postgres database. The Postgres database, as any other relational database, is just a backend service. It is, you send SQL-based queries to it and get tuples of data back. And that's it. That is the way how you communicate with it. And there is a special transport protocol that you usually use to talk to that database. It's based on an internet protocol. So databases come without user interfaces. That's the point. And there is, however, standard user interfaces. And I hope I have pgadmin at the start for now. Let's see. Here it is. That is the user interface that is running on my Postgres here. And actually it's web-based, but you need to install it. I have not understood why. Who cares? You start it, and then you have a list of servers. And in this service, you have a list of databases. And in the list of databases, I have full messages, JestDB, PartyAppDB, Postgres. I have no idea. This is for administrative purposes of Postgres. Don't touch it, I think. I have no idea. Let's have a look at JestDB. That is the database that I was creating. It's an important thing that you get this in your mind. You have one database system that is actually a service running on your computer or on some computer which has a URL that you can connect to. In the database system, that is actually the program you are talking to. You can have multiple databases, which is actually a bunch of data. And a database has a lot of tables. So the hierarchy is database system, database, table. This is important because each of these things can have its own name. And in a large microservice system, you can actually decide on we use one table per event store. So we could actually have the warehouse table and the shop event table in a single database. Don't do that. That is not a good idea. We will have separate databases because then it's easier to move one of those databases to another location. And actually, if you consider moving a database to another location, then you actually should have separate database systems, so services that you are talking to, in addition to. So each of those two things here, the shop and the warehouse, will finally use its own database system running on a certain computer with its own database and its own database table. That's an important point. However, for testing purposes, I will run only one database system on my local small laptop here, and I will put two databases into that single database system, which is okay for testing, but not for a productive system. And again, you need to be aware of that when you finally have installed your thing on Heroku, that you have, well, on Heroku, your productive system, where you actually have real-world customers that are using your thing, well, actually the tutors using your thing and having a look at it. And when you do further development and testing, then you have another database for the testing purposes, for development purposes. So we call this staging, that you have database that you use during development and testing, and another database that you are, or database system probably, that you are using for productive system. And we need means to switch between those. However, we will start with just testing. Okay, let's have a short look in the jest database. That is the one where I have written a jest test for. And there is a schema here. And the schema has tables, actually two, that's funny. Messages, which is an old one I have created, I don't know why. And events. And events is actually the one that I would like to look at. And I use a trick here that says view edit data, which is an all rows, and then run it. And it says, no, there's nothing. Oh, yes, it is. There's old data here. I have no idea why. Let's update this thing. Okay, servers. Can I enlarge this? Yeah. Jest database, schemas, tables, events. Okay. Count rows. No. All data. View data all rows. Here we are. That looks good. This is a table I was creating during testing. And it has 4 columns, a topic, an ID, a start time, and some JSON tags that you can have a look at if you double click on this and then enlarge this a little bit. You see, this is a JSON data for one of our events. It says it's a products event P40 on that date. The user who is actually sending it was PG test, it's instead registered, and the payload is a barcode with P40, a blue LED, and it has an image URL. So this is the data we are dealing with usually. And I actually have stored this into our table, into the JSON field or JSON column, and have some extra columns here that I use to look up certain events. So the actual event is stored in the JSON column. And then I have a topic and an ID in order as a key to access this. And there's this start time that we will use in 2 weeks from now. So that one is too early. You actually do not yet need it. Just ignore it for now. We will have it in our table. I have told you it's hard to evolve a relational database table without, well, throwing it away. and therefore I just put it in there. This is not really necessary, but I think it makes things easier. Okay, so how did I, do this thing? I have run a PG test, which is this one. You need to extend your package JSON. You need this yarn install. Then you can have this one here. And is this big enough? Yeah, if I get this one out of the way. Get that one out of the way. So I have set up a test. And the first thing that you need to do is you need to connect to your database. Your database is running as a background service on your computer or on some computer in the internet. So you need to access it. And you do this, for example, via a URL. So you says, I would like to use the protocol PostgreSQL. That's a protocol like HTML that is used for this database. // Then there is localhost is the computer where this database server is running. This is the port that I am using. It's the default port, I think. And I want to log in as Postgres user, and this is my password. It's gone. Actually, the default password for Postgres is Postgres as a user and Postgres as a password. And actually, you can omit the defaults if you use those. Then you can just say, I would like to go for localhost 5432. I recommend that you set a password and that you might change the user. That is not this important. However, this URL that we have here will later on, when we go for Heroku, be constructed out of environment parameters. So it is important that you know a little bit about this. So the next thing is the tutorial I'm using. Let's have a look at the tutorial. Is this one? No. So this is where you can find the Docker Hub. This is where you find PostgreSQL documentation. This is where you find the documentation how to use or connect to Postgres from TypeScript or from JavaScript or from whom I do not know. And it says this one, it's a good idea to use a pool. And we will just use a pool because, for good reasons, let's do that. And so what I do is I create a pool and tell it this is where you can access the database. And then I ask the pool to run a query. And that one is just for testing purposes. It's not default or standard SQL, but it's select now, it's just giving you system time. So you do not really need to go for a database table, but that one is actually going just to deliver you the time that is on the database server. Should be localhost, should be the time shown in my thing here, my local time. That one, oh my God, how much time do I have? 1 hour gone. This is actually doing a request via the internet. So your program is asking the the Postgres server for some information to execute an SQL statement. And this is an input-output operation that needs time. So on my computer here, you can have about 100,000 of such requests per second. if you go for a database server which is living in New York or in Los Angeles or in San Diego or in San Francisco or at Google site or somewhere, it needs to go to Frankfurt, through the cable, to New York, then to the east, to the west coast. This will need about 3 seconds. And therefore this is a long time, and therefore this is an asynchronous execution. So you actually, this will only deliver you a promise. So you do a wait in order to wait for this one. And then you get the result and to print it, and that's pretty much what we do here. Let's run it. Yeah, but I don't see the question in the chat. I don't see the chat. Let me see the chat. There is the chat. I think I have all the links in the on my slide. Yeah, probably you should have it. So it's actually, yeah, you have this slide here, and here is the link to Postgres download. Yeah, and we do not have the link to this one. And this is TypeScript PG doku. Yeehaw. And then the other one was, oh, that's the important one, I think. Yeah, ask me again when we do that. So this one was executing. I'll put this down a little bit and let's see what this is doing. So it's giving me a console log and says it's 11:56. Our lecture is about to start in 5 minutes. No, it's Zulu time. This Z here says it's the 0 time. Actually, the Z is 0, and it's somehow it's called Zulu time or 0 time, and it's UTC time, Greenwich time in England, so time zone with 0 of that. And therefore I'm living in Central European Standard Time, CES time, which is 1 hour ahead of Zulu time or 0 time. Okay, cool, that one worked. And that is actually the very first thing that you need to get running in order to get all the seeing stuff. So then the next thing that you need to do is you need to create a database. So you have a connection to the database server, but now you want a database in that server. And that is not coming by its own, but you actually have to create it. And one way to do this is to send an SQL query, a statement, which is called create database jestdb. Never forget the semicolon here. It's part of the statement. The statement doesn't close if it doesn't have a semicolon here. I'm not sure whether this actually needs to be uppercase. However, the name of your database needs to be all lowercase. If there is an uppercase letter here, that one will be converted to lowercase automatically, and then you will not be able to access your database afterwards. So it's just ridiculous. And well, how do I explain that? Whenever you come to software that has a problem with upper and lowercase letters, like Windows, then the reason for that is in the late 70s or 80s, some 40, 50 years ago. So when the very first computers were developed, they used Fernschreiber. I have no idea what the English word for that one is. well, it's actually two typing machines connected by a phone line. And there was a standard for those, well, phone line typewriters that only used lowercase letters. Teleprinters. Okay, and the teleprinters were only using lowercase letters. And the early computers adopted these. And so if you have software that still does not distinguish between lower and uppercase letters, it has its root in the early 80s or late 70s. There, they did not have it. And then they didn't care. And so SQL stems from, well, ancient times. So it was, well, there were still dinosaurs living at those times. And you do not, and that's really old software. And it has these problems. Okay. And probably this is successful and we will run it soon. Once you have created it, the next thing that you need to do is you need to create a table. The create table problem or command is a little bit more complicated. And it's this one here. And it says create the table if it's not yet there. Call the table events, again all lowercase letters. Then you have a number of columns. The first column is a topic. The type of the column is varchar for a string of arbitrary lengths. It should be not null. Then there is an ID. There's a start time that we will lose into weeks. Then there is your JSON data, your actual values, which is again a varchar. And then you say, okay, I have a primary key. So I did quite some research to come up with this table structure here. Please just stick to it. Copy it for now and I will explain why it is this and nothing else. And we will discuss this during the lectures. Last year, when I was giving the microservice course, I was doing this with type ORM, type object relational mapping. And we're using just the same thing, but I have a JavaScript class or TypeScript class, which was called event data transfer or something, and that had exactly this structure here. And then I asked this object relational mapping something to create the table for me so that I did not have to send this one. This year I said, actually this type ORM was quite painful to use last year. And so I decided, it's not worth it. So actually object relational mapping is very good if you have, some 10, 20, 50 classes that you would like to create tables for. If you only have one class, it's not worth it, from my point of view. But actually then you have to dig into your lecture on relational databases and on SQL and to come up with this here. Okay. So let's do it. So where do we do that? We go for the submit handler here, which is the one who is actually accepting new events to be stored. There is also the query handler, which is just doing queries on the database, and we will use that one too, but it's later. So let's start with the submit handler. And the submit handler had this event store here. Can anybody see this? There are a lot of questioning faces in the Zoom window. You are fine with that? Can you read that? Yeah. Some smiles are coming up, some thumbs are coming up. Cool. So that was actually a map where I could ask with a topic like products for another map where I could use an event ID to get a list of events on that ID. So if P40 is my shoes product thing, then the topic is products. I ask for products, get a table. I asked for P40. And then I get all the events that has been raised on my shoe product. And that would have been, well, shoe product created, and then it's registered and whatever. It might have been delivered or whatever. Okay, so actually that was very handy for explaining to you what's going on. And this event store would actually keep track of all the events that we have ever raised in our whole system. And that is a good thing to have. After all, if you would like to do historic analysis of something that has gone wrong, that you say, okay, something is wrong with this product or with this order, so who was working on it on which point in time? However, for actually running your system, you only need the most recent events, because that's your current state, what you are operating on. And therefore, well, actually, I will drop the history for now. And we will have to discuss again, don't we need this history and how should we get it? And perhaps we will have a second table where we actually keep old history data, old events that are no longer valid, that have been overwritten by new events. Or we might actually use something, another database where we send those events to. And then we could have one database for logging that is used by all our services. And then we could actually also see if there is an order by Alice for red shoes. Then we could see, oh yeah, the shop was doing these things, or then it was in the warehouse and the warehouse was doing that things. And okay, here it went wrong. So we could have a common log that spans all our services. That is something that you frequently have in microservices systems. And actually there's dedicated software that helps you on that. You can have actually something like Logstash. We might have something like that if Sebastian wants it. Or we can have it ourselves. We will see. Okay. So for now, we forget about the events that are no longer valid, that has been overwritten, and we will facilitate that because our thing does something which is more simpler. So here's the constructor, and usually I say don't do complex things in your constructor. So today I will do complex thing in my constructor because it's the simple place to do it. And the first thing that I will do is create the database. Because it might be that we connect to a new database service which does not yet have the database. This one is not yet existing. So I asked him to declare that method. Here it is. And it throws a not yet implemented error, which is wrong. I just do that, implement that. So basically what we want to do is this connection on these things that we have in the test. So I just copy it. We do such a connection. And let's have, so that's this my thing. Later on we will have variables here that says, oh, am I productive or am I testing? That's the basic thing I want to have. And I want a pool that I can run the queries on. Actually, you could have a client. The documentation says, oh, better use a pool. And so it has to do something which how the connection between my program and the database service is reused for a longer time. And the pool is going to reuse this a longer time. Oh, my mouse is gone. It's actually gone, is it? It's broken. Damn. Ah. Don't panic, it's just the battery. Ah, here we are. So, the pool. Cannot find the pool. Import pool from PG. That's it. So you need to install PG and all these kinds of stuff in order to make that happen with yarn art PG and types PG and these kinds of stuff. And then you can actually have a pool. Yeah, that's fine with me. And then we go for create a database. And we just copy all this stuff here, put it in here. Let's see. It says, oh, you do an await. If you do that, you need an async here. And we should probably do, can you do an async await in a constructor? I don't think so. So it's not a good idea to have it in a constructor. So we will have an async method called init or start. Let's call it start. That's a good one. And there we will call this one here. And we will do... No, there's no need to do an await here. We can do it, have it in the uppercase. Oh no, yes, we need to do that. Create database. Yeah. So, pool query create database, and let's call it a different name. Let's call it test, and we are in the warehouse database. Test warehouse database is a good name for me. Probably those names cannot be very long. So do not use something like 250 characters here or 300, that might not work. It's ancient technology, they didn't have that many characters in 1970. Yeah. Let's have that one. Cool. Okay, this one says, oh, you need to close the pool at some time. And actually, I took this from the documentation. It's actually the pool opens a connection to your database and keeps it open in order to let you have more queries on the same, post or on the same communication between client and server. And database server. And if you say pool and, you actually close that connection. If you forget to close that connection, then it will eventually time out. However, if you run those tests 100 times and open 100 times tools, there is an upper limit for connections that your database server is accepting. And actually the documentation said if you do that, run a test script that does not close the connection, and you run it frequently on a productive system, it may happen that you're running out of connections and that your real world customers can no longer connect. That's no fun. So you close your connections. And actually that pool thing here could be reused for quite some time. However, the next thing that we need to do is we need to create a table. And this will probably again going with an await. Declare method. Here it is. And that one is adding to, and that one will use another URL. And therefore it's probably a good idea to close the old pool and use a new pool now. Okay. So copy these things. So, and again, what we do is now, we do no longer want to connect to the database server, but we want to connect to our database. Therefore, we add the name that we used to this URL and say, please open a connection and directly go into that database. And that gives us a new pool where we can run a number of queries on. And the query that we want to run is create the event table. So I also have a drop table test here, and we will have to discuss this one too. If you run multiple tests, each test adds things to our table, to our event store. And then the new test, well, wants to ensure it's not yet there. I add it, now it's there, but it's already there from the previous test. And then we are in trouble. So we might need to reset our database from time to time in order to run tests on a fresh, empty database. Therefore, we will need to drop tables later on. For now, we just do the creation. And it's all in here. And why doesn't it have a try catch? I have no idea. Okay, we do not need that one. We do not need that one. Here we are. So we create the table with the structure I've shown you. You need to probably retype this. Should I do that on the web page? No. Now you learn more if you actually type it. Yeah, it's better. It's better for you. So you do a pool query. That should actually create the table. You come here. If it works, you end the pool. Actually, we could spare that one, but it's probably a good idea to have it. And actually, I wonder whether this pool end is going to be reached even when this one fails, if it throws an error. It looks wrong. Really? So why don't I do this pool end anyhow? Whatever happened, do a pool end. Here it created a pool, so now I do a pool ending. Yeah, that's better. And I should use try catch on the thing here. And it should probably, close somewhere here. Sorry. Should close. Sorry, keyboard messed up. Here we are. And it's formatted now. And it should have something like a catch error thing. Okay, and there are some of these are missing here. Oh, damn it. Okay, here we are. We create an SQL statement, we send it. If it fails, we don't care. And we do a pool end. And if it worked, we set this one out. Okay, that should do the job. And we have 10 minutes left. Oh my God, we need some more time. Sorry for that. I will do, again, running overdue time. I'm sorry. We really need to finish this today. So actually, we need to ensure that this one is actually called the init operation or the start operation, so that these things are prepared. And this needs to be done in the routes TS. Here we create the submit handler. So we can actually say submit handler dot start. And that should connect to our database. And that should actually create our initial table if it's not yet there. So we are ready to go. And now what are the operations that this submit handler is actually offering to us? We will use that one later on. That's not for now. So there is this get latest events thing. Is that a good one to start with? Yeah, that is a good one. That one gets a topic, and then it goes to the event store and asks for all the events that are coming to that topic. Actually, you get a list of those things, and it also from all these lists, it takes the newest topic. So we will actually implement this in a different way now, and therefore we will actually put all this thing here. Yeah, just kill it. Yeah. So we do no longer ask our event store. Yeah, we will have that thing, and we probably need that one, but in a different way. And so we are going to ask our database system, please could you give us all the events you know about products, for example. And therefore we do the standard thing. We go for, damn it. We open the pool. Yeah, let's have all this thing here. Go for get the latest event. Come, let's get rid of all this stuff here. And put this thing in here. Let's get rid of that one. So, connecting string is we go for test varies DB. It actually should be something that is global to our system. Yeah, let's have it here for now. No, that's no good. We'll have it all the time. So it should be part of the constructor. And let's have a let here. Come on. Such that we can actually change it. Oh, then we do not need anything here. It's an attribute. Connection string is now above here, and it's suspect to be here. We use another one because. So let's call that one the DB connection string or database system connection string. Just that those two get not mixed. Here we will actually use the original connection string. So we can say this dot connection string here. Okay, this any. So why? Should it be a lowercase string? Yeah, probably. So what is wrong with this one? Sorry. So there's something wrong above. Connection string is a string initialized. Done. DBS connection. So why doesn't it work? Can anybody see the problem? Ah, come on. Show fixes. Yeah, please. It looks good for me. Okay, and it's yeah. So what was it before that? Yeah. So it's connection string. Damn it. Okay, calm down. So copy, copy, copy. It doesn't copy. Copy. Paste. Colon. Format. Connection. And that one here is just plain wrong. Here we are. Thank you. Yeah, of course. Okay. Create table if not exist. Create database. So this one needs also this connection string in front of it. Copy. Please copy. Love it. Okay. So, and now it's totally wrong. So the create database needs this thing. And the create table 2. Let's get rid of that one. DBS connection, okay. And we have this overall connection string here with the database thing at the end. Yeah, and then it's not here. Create table. Oh yeah, it's in the, come on. Okay, we don't know that one. Just give the old man yet another hour. This dot connection string, yeah, this connection string actually has the database name already in it. So I think I have it now. Just put that in the correct order. So it's Control X. So it's first create the database, therefore I connect to the database system. DBS connection string, create the database. Then I create the table. I can use the whole string with the database name already in it. Database name in it. That is the database name. That looks good to me. Create table should do the job now. And so now we are at this one here. And I can use connection string, this dot. Connection string, great. Then I have a pool. I have a SQL statement, but I do not want to do a create table thing. But I want to do a query. And I have prepared that. Be query for all events. No, I don't have it, but that one will do the job. And we will just discuss it. So, you know, here you see this tick here. It's a backtick that we use to, well, for string templates and for multi-line string constants or strings. And another one is clothing here. Very important. It says, get latest events. I want topic, ID, start time, and JSON, which is all the columns. I could have a star here. That is no. You always elicitate all the columns you are looking for, because your table may be extended later on, and then a star would deliver you rows with a different structure, and the code that looks up the structure would fail. Therefore, you say what you are looking for. Topic, ID, start time, JSON is all these things that we have. From the name of the table is actually events. Is this true? You wanted to have events as the table name or something more sophisticated? Warehouse events or something? I don't care. Let's stay with events, then my prepared code works better. And I want these things where the topic is something that is provided here. So it is $, topic. So you recall that this backtick quotes go through this string, looks for $, braces open, braces closed, and curly braces. And there, the code in between those is going to be replaced by the value of that variable or expression. And so whatever we pass as a parameter is then between those ticks in here. This is the string that is going to be parsed as part of our where clause. And so that should actually deliver us all these things that have this topic. Cool. We run this SQL thing here, and then it says, okay, therefore this needs to be asynchronous. Or we could not wait for that. That is a problem after all. Get latest event, probably, I'm not sure about it. And so no, that's no longer the thing that we would like to give as a result. And we get a lot of rows as a result. Let's have a look at what is actually coming out of this. And therefore, I will probably rerun the test. It doesn't compile any longer, so it doesn't run. That's bad. Let's fix that for the moment. It does not need to return anything. So we will change that later. Here we go. So that one is actually doing a retrieval, and it should be the very last thing. So actually this is one of the things that you get back from this request. And you see it's a JSON object. And actually that JSON object is already gone down to something more special. So let's have a look at that. It's the very last one. You get a result. The result has rows. It also has a row count. And then you can actually get row by row. And the content of the row is actually a JSON object that you can then go into more details into it. And actually, I would like to... So this is actually one row. And what you get is something which has a field, a JSON object, which has a topic, an ID, a start time, and a JSON field, which contains a string that you then can unpack, and that's your actual event. So what we go through, we do a loop through all the rows, and then we will actually for each row grab the fields, and then we are done. Okay, and I'm sorry, I still need some time. It's more complicated. I thought it would be easier. So there's a result. So the result should have rows. And we would like to do a loop through that. And this is done for const row of Sebastian, is this okay? Yeah, he looks confident. So this is a list of rows. And so the row, we can ask for, please give me your JSON. Hopefully. JSON string. If you go back for this thing here, come on. You just accept this field and get this thing here, which is a string that we then need to parse. And hopefully Sebastian knows how to parse this. Is this going with JSON? So it's this JSON.parse. And that one gets the JSON string. And what we get back is an event. Hopefully. And let's check again what we get. Yeah, pretty much looks like an event with a payload and everything. Cool. And that is what we were asking for. And therefore get latest events. It should be delivered in something like a list of events. It's a const. Come on. Event list, where it's of type event array, and and it is going to be initialized like that. And so this one is going to return an event list. So at the end of this for loop here we do event list. So how do I rename that? Our event list dot add or push. Push the event. Great. So, and then we do we should always do a pool n. That's probably not a good idea, but I'm not sure. And then we do a return event list. And where would she actually do that? The event list is here. Yeah, might work. We should do something here. I love it. That will do the job. So we do not yet implement the get event history because, well, actually we don't have it anymore. And actually what that should actually, oh yeah, just give us the last event that we would like to have. So copy it. It says it's not going to work. So what's wrong? Import event. Yeah, that's true. Okay. So the event history is going to be used to, well, it will actually just send me not really the list of all the events, but only the very latest event. And it will put it in a list for historic reasons. That's no good idea, but who cares? So we want this async. And then it should be a promise. Because we actually do not deliver it directly, but only deliver a place where we are going to deliver it. And here this one needs to be extended. And ID equals straight single colon, dollar, curly braces, ID. Yeah, so we have a topic and an ID. And so we go into our database and look for topic and ID, and we will have exactly one entry for that one. And that should be in the result. And so we do not need to do, yeah, but why not? We get one row, we can keep that, so actually it would be enough to just have one. And it will deliver the empty thing. Yeah, I love it. Yeah, cool. Implement it. Done. So these are the queries that our system is using. We were using our in-memory event store before, and now we replace that with queries to the database. Okay, cool. And then there's this put into event store. That one is a little bit more tricky. And we will probably use something that is pretty close to these things we have had before. So I copy this, put it into here, and then we will speak about it. We do not need the event list. We connect to the pool. Then we do something. And I copy this from my test. And well, that one is a complicated one. Here. This is the SQL that we are going to use. And I put it here. Be sure that you really get the end of this very, very good. Insert into events. This is the table that we would like to add things to. Then I name all the columns that I'm going to store. Topic, ID, store time, JSON. Then I provide the values that I would like to put in here. And actually I could insert multiple rows in one statement. I could actually have as a value a list of rows, but this time I only use a single row. And this is in braces, in round braces. And now I have value for each of these. I ask my event for its topic. I ask my event for its ID. Then I need something which is a store time. Damn it, I don't have a store time. I actually, okay. Use something ridiculous for now. We will have a better thing later here. But today is too ridiculous. So it's 2021, it's 01, it's 18. That is it. That is good enough. And then the actual data that we would like to store. And therefore, I go for my event and do a JSON.stringify on that one. On the event. Come on. And for readability, I do a null and a 3 to actually pre-printed. Because if those strings are not pre-printed, they are barely readable. And I put that into a string I call JSON for JSON text as a shorthand. And then I can parse it here. And so this is what I actually store. Cool. So it says if you want to do a wait, then you should be othering. Cool. And yeah. Yeah, that's cool. You get something as a result, I have no idea what. You could have a console.log for it and then look at it, but fine. So this one actually now sends this query out, this insert query. There is a problem with the insert query. It may fail because insert expect that the primary key, which is the combination of topic and ID, is not yet used. If you already have a row with that primary key, you need to send an update instead of an insert. So hopefully this one here throws an error because the insert is not working when we do this the second time. So if we have a red LED that we have added to our products, and then we switch the color of that LED to blue, but use the same ID, which was P40 or something, I have no idea. Then we want the old data to be updated. And therefore we go for the try-catch error thing here. And I will actually copy this because it's a pretty other syntax if you do an update. So this is how an update is done. We are almost through it. No. Yeah, it looks good. And there's still something that we need to adapt. Sorry. So the update SQL statement has a different syntax. It says update in table events where the topic is event topic and event ID, which should be just one column, one row, and then you set store time and JSON. You do not assign topic and ID again, because this is your key. You cannot change it. It's actually forbidden. It will throw an error if you try to do new value on that one, because this would be, well, destroy the sorting that the database is going to do on that. And therefore it's forbidden to change those. And that's the point here. Okay. That should do the job. We should actually run that one. So this is a new SQL and a new result, and it actually should have a new try. Catch around it. Here we are. Yeah, come on. I think I put that one in a new line usually. Okay, so we first try to insert it. If that fails, we do an update. This is tricky. Actually, we have a database transaction problem here now. If we run two such push operations in parallel, for some stupid reasons, we first try to run this insert that is being called by Alice. And it fails? Yeah, it fails. Because there is already such a row. So we go for the update. So however, here is an await. So when we run that one, the Node.js is going to run some other things. For example, the request that came from Bob. So now Bob does this insert thing. That one does an await too. So the scheduler does something else, and then sometimes later it looks up some of the jobs. The one of Alice or the one of Bob, who knows. And perhaps Alice, so then the Alice update is done, and finally the Alice, then it's again an await thing. So maybe now Bob's thing is done, and you have no real idea how those operations of Bob and Alice are going to interfere. And it may end up with anything possible. That's bad. Sorry for that. should not happen. You could avoid this by making this insert update into an atomic operation. You could have a single database transaction that does this, a single SQL statement that is called upsert, update and insert in one step, which has a quite complicated syntax and which is something that Postgres offers to you, but MySQL probably does not, I have no idea, or in a different syntax. It's no standard SQL. So what you would do in a standard SQL thing is you would start a transaction and end a transaction. However, I don't care. That one is pretty much the same thing here. And finally, one of those transactions, the last update wins. If I do use transaction or not, I don't care. Both ways it will work the same way. But it's a tricky thing, and it would not work if you first try an update, and if the update fails, you try an insert. Then perhaps both Alice's update fails, Bob's update fails, both try an insert, and the second insert would fail. I've been through that. So the first try insert, then do update, then you are pretty fine. Here we are. That should do the job. So all we need to do is, well, repair the query stuff. And, well, actually I try to, well, show you what to do and will not really show it through the lecture in order to come to an end. You should be now able to deliver this yourself. But have a short look at the query handler. The query handler has this handles thing and asks the submit handler for latest event. Oh, it's done. It should work. Well, actually, it says, oh no, you only get a promise. So what we need is an await. If you do an await here, we need an async here. If you have an async here, someone who is calling us is going to fail. But that one is actually done in the root TS. And that one is happy. Query handler, handle, no problem. He can deal with the promise, probably. Does he? Sebastian, do you know? Or do I need an await here? Let's have an await here. It's better. And an async here. Yeah. So we probably have it here too. And we'll have an async here. Because the handle that we use here is going to become asynchronous. That one is the model command handler. And then the product command handler does an async. Probably, and then you can do an await here. You're almost done. Soon it will compile. Yeah, that one is using this get event history thing and nothing else. That should do the job. It's pretty fine. And then there's this product command and supplier command handler who just has the same problem. Async. So that's a pretty frequent thing. As soon as you start with adding these awaits, then you propagate the othering, then you propagate the await, and so on up to the top level. Okay. And there's this user command handler. Sync. Await. Love it. Yeah, should do the job. Let's look at one of the jest tests. The order test, for example. Run. Yeah, run test. That one runs all the tests. Keep your fingers crossed. I would wonder whether this is probably going to fail. However, no. Some of them work, some don't. I will fix it at home. You guys will find out yourself. And so I come to the end. It's pretty much the thing that you need to do. And so the homework today is just add a database for our warehouse event store and make all the old tests run again. So replace the in-memory event store with the database and make everything run again. That's it. And well, I have a little advice from myself. It's a good idea to start with the database test first, with this PG test I have, just to get the connection done and these kinds of stuff. It's the very basic thing that you need. And you probably will need to, well, drop the table once your test has finished or before your test starts again. For example, when you ask for, you want to pre-register Bob, and then you go for the other one, which shall not yet be registered. Then you need, but it's in your database from the last run. So the content of your database will survive the test run. So before you start a test, you might need to reset the database. And the thing how you do that is you can either do a delete and then say which rows you do not want to have any longer, or you could actually just drop the table. And let me do just that one. Yeah. Drop table, and then we are done for today. I do that in my PG test all the time. So it's this is the SQL command that you send if you want to kill the whole table. And it does this, not asking any question. If you have the credentials, you can log into the database, you can say drop table, and drop table will drop it, not caring about how many millions rows of data are in there. You can actually destroy millions of data in a second, in a millisecond. Now all the customer data you have, for example. Okay, so finally, I'm very sorry again for going into overtime. Thank you for your patience. I hope you are going to deal along with that, and I hope that it works. And next week we are going to, well, start with the shop. Actually, we need to extend the warehouse a little bit to actually have data in there, goods in there that we can actually put into the shop. And then we will actually do the shop, and then we do the communication between those two, the warehouse and the shop. That is the one interesting thing that's missing, and that will be addressed next week. Okay, thank you for your patience. I stopped the recording.